Hello everyone, topic for today is NLP meets human learning, NLP research and applications in human learning, how we leverage, innovate NLP solutions to better support human learning. I'm Junjin, a senior machine learning scientist, science lead at Amazon, working on understanding how we learn, how we each individual learn, and how we could improve the way we learn. So human learning, quote unquote, starts at birth and continues until death as a consequence of ongoing interactions between people and their environments. The factors contributing to effective learning are of various kinds, such as food, emotions, age, surroundings, etc. And the focus for today is e-learning, where learning science principles are applied to deliver the learning experience, and learning data are captured and collected as evidences, and then NLP solutions are used to analyze the learning content and data and then provide insights for better learning design. So, where and how NLP can support human learning? The scenarios are for learning design, how to locate the right content for designers, like an information retrieval task in delivering a learning experience. Second, how to help designers understand the raw content if the content is domain specific and designers have no background knowledge. And also how to create an effective assessment throughout the learning experience or at the end of the learning experience so that learners can practice what they've learned and be assessed. And for learning, the scenarios are how to estimate learners' knowledge states through their open-ended responses, how to identify learners' knowledge gap, how to provide tailored feedback. Here's the agenda for today. We'll go through the papers listed here to have a glimpse of how the topics, I just mentioned. The papers are delivered and published in the last 2 years, an effort from my team. 4 sections to dive in: computational cognitive modeling, question generation, targeted feedback generation, and conversational agents. So the first topic, computational cognitive modeling for human learning. What is the cognitive model of learning in this context? It is a covert mental process of human structure and develop the knowledge within a subject area. Because of its covert nature, it is challenging to estimate accurately. Thus, the way we tackle it is to collect learner data, especially their performance data on formative assessments, and build models to discover the learning patterns. And the hypothesis here is that the different learning patterns indicate different cognitive processes. Thus, by analyzing the learning data, we could extract potential cognitive processes. And NLP techniques involved your basic topic modeling, text summarization, and state-of-the-art language models. We could take a look on how the overall cognitive modeling framework works. And the NLP is just one of the modules of the framework. So in the overall framework, first we apply behavior factorization to get assessment representation, and then we apply Gaussian mixture model to get the clustering result. And after that, human actors come in to evaluate and interpret the data insights, within which NLP is used to understand the learning content that is designed in the learning experience. And the purpose of using NLP is to interpret the intention of the learning design from linguistic perspective, and then compare it to the exact intention designers have when they're doing the initial design, so that we could see if there is a misalignment. And also we'd compare the inferred intention with the learning data to see if the behavior is expected, or the unexpected behavior tells us something we don't know before. For example, a designer attempts to create an assessment for evaluating a skill. The skill is identifying a concept. And assessment is designed with a single choice selection as the question type. And the expectation is that the learners could get it correct with 2 attempts at most. Because the assessment explicitly uses the word identify, the NLP module could easily infer the assessment is for identifying a concept. So after compared to the exact intention, the inferred intention is pretty aligned with the exact intention, which is great. However, the learner data tells us that the majority of the learners attempt 3 times to get it correct, which is 1 more attempt compared to the expectation. Thus, a call out is surfaced to the designer to take a look at assessment. Something is not doing great, probably the wording is confusing, or the content is not clear enough, or the distractors design are too close to each other, etc. That is it, the NLP for cognitive modeling. Here comes to the second topic, which is question generation, which is a popular NLP task. The application context is as follows. Assessment design is very critical in learning design. It is used to evaluate the knowledge state of a learner and enables the personalized adaptive learning for the learners. And for the knowledge or the skill that is technical, complex, and designers who has not enough background knowledge would struggle in understanding the material and coming up with quality assessment. Let's say we want to deliver a course for coding skills, and the course designers might not have the breadth and depth of the knowledge about how to code. So the goal here for this research is to assist designers in 2 ways. First is to help them understand the concept of this content. Second is help design assessment that could be used to assess learners' knowledge state. And of course, the human actor designer is still the main actor that consumes the help from NLP, the algorithm, and to deliver quality assessment. And the related NLP techniques are text summarization, question generation, and sequence to sequence. So the approach we proposed and works well is as follows. Given a piece of content, we use pre-trained language model to provide a succinct version of the content, which is summary. We use both extractive and abstractive methods for summarization. That means the summary can be either keywords extracted from the content or a generated short sentence which expresses the concept in a natural way. After we get the various summaries, the designers would review the summary, select one of them or rephrase them with their knowledge, and provide an answer to the question generation module. And the third step is to generate a question based on the initial content and the answer, that those are the input for this module. And at the end, designer would review the question and fit the question into the use case. So the main idea here is to use NLP to assist assessment design by helping designers understand the content, producing some kind of question to start with in their design. Here's an example. So given a paragraph, create an assessment. So this paragraph is about what is Amazon VPC and what benefit you could get from the AWS service. And the expected summary is either a high-level summary like Amazon VPC benefits or some keywords such as virtual networking environment. And the expected assessment is as simple as what is AWS VPC? And this table lists out the result from different approaches we applied. And here's some interesting finding in our context. That regarding summarization, both extractive and abstractive methods work fine. Extractive methods produce keywords, and abstractive methods are unable to depict the keywords in a more natural way. And regarding question generation, no matter how the answer is prepared, you can see the generated question are meaningful to some extent. In other words, the generation step is robust in producing the questions. And there are more insights around the benefit of fine-tuning the language model and the benefit of human intervention. Please refer to the paper if you're interested. All right, so here's the third topic, which is the targeted feedback and insights. One big expectation we have for tutoring system is that they can generate targeted feedback to learners like a coach. There are two benefits of such a feature. One is learners can receive guidance at any time when they need it. Another is it frees up time for instructors to focus on other important tasks in teaching. So what have been excessively researched is how to conduct auto-grading. Auto-grading is helpful, but that is not enough because we want feedback beyond just a grading score. And for open-ended constructive response question, we need to understand learner input before offering feedback. Thus, here's the NLP part. And the difficulty lies in understanding the semantics and then provide guidance based on the knowledge gap. So here is the solution we came up with for constructed response question activity. We first segment learner answer and model answer into chunks. Then we extract the semantics from both learner answer and the model answer and then compare their similarity at the grading point level. And after that, we derive what is answered correctly and what is not. And then we provide feedback based on what is not answered correctly yet, because that is the knowledge gap or the misconception the learners need more practice on. So here's the worked example. Designers design 6 grading points, and we compare learner answer point to the grading points and provide feedback on the knowledge based on the knowledge gap. So I don't think we have time for the details, so check out the paper if you're curious about how it works. The last topic here is about the conversational agents. One big concern for online learning is it lacks of face-to-face or in-person practice opportunities. And in-person practice opportunity is very important, especially when we are developing communication skills, interviewing skills. Thus, we want to explore the opportunities voice assistant could provide us. So we explored a bit about how Alexa can help us in learning experience. We designed 2 roles for her. One is peer role, another is a coach role. As a peer, Alexa expected to understand what learner is communicating and then respond with her own wit. As a coach, Alexa is expected to whisper to the learner on what needs to be improved. So in order to support these 2 roles, we developed a configuration-driven engine. So in the framework, we have modules of voice recognition, scenario identification, branching, conversational status tracker, natural language understanding, and nudging with hints. So what Alexa would do is to understand the utterance, identify the branching scenario, respond with some predefined rules based on what she's hearing. So we implemented a real application for supporting and developing an interviewing skill. In this application, Alexa serves as a peer carrying on the conversation and also a coach providing hints when learners get stuck. So I think that's all I want to share for today. And we don't have time to go through each of the papers for the details, but definitely if you're interested, take a look on these papers. Thank you all.